Welcome, ladies and gentlemen, to another video by Mark Anderson for Kellogg Community College, and we're going to look today at finding intercepts of parabolas, and we're also going to talk about the discriminant. So we're going to start and end this video by looking at ways to write the answers for parabolas for where they cross the x-axis, otherwise known as writing them as x-intercepts or zeros. And in the middle of the video, we're going to take a look at our good old friend, the discriminant. The discriminant is created by part of the quadratic formula and can be used for all quadratics in the form of ax squared plus bx plus c. And let's begin. We're going to start off by looking at ways we can find x-intercepts of parabolas. And if you've watched previous videos of mine, or if you're a student of mine, we learned basically two simple rules. The first thing you should look to do is to factor. And factoring is going to give you the quickest way to find the quadratic, or to find those answers for when x hits the ground. The second option you can choose is to use the quadratic formula, and that's really nice if factoring is not an option. But I want to give you a zero rule, a rule that I actually hadn't mentioned yet because it's pretty janky. But really, graphing the equation, and since this is the graphing section of our work here today, we're going to take a look at how graphing can maybe circumvent these two if the answer is pretty obvious. And sometimes the answer may not be obvious, but the third step I will say that after you try either one of these three methods, because completing the square would not be better than quadratic formula for most of us here, we would write this in terms of x-intercept form, and the intercept form is going to be with an x comma 0, because that would indicate on a graph where we would be on the x-axis, either to the right in the first and fourth quadrant place, or to the left in the second and third quadrant place. All right, or between the two of these and between the two of these. So let's just do quick factoring here to show you what I mean if, because this problem right here is going to be factorable to x plus 1, x minus 1. That's a difference of squares. And if I set these equal to 0, because I want to know when y is 0 or when it hits that x-axis there, I could have 0 is equal to x plus 1. Subtract the 1 from both sides, x is equal to negative 1. And here I have x minus 1 equal to 0, and subtract the 1, and x is equal to positive 1. So my two answers are negative 1 and positive 1. To write my answers in the x-intercept form, we would write them with 1 comma 0 and also negative 1 comma 0. These are the two intercepts of the parabola. The same thing goes here for this example. This can be easily factored into x minus 2 and x minus 1 because those are two numbers that make negative or positive 2 and add to make negative 3. If I set these equal to 0 because I wanted to find out when this hits the ground or when this hits the x-axis, then my x is going to be equal to 2 and my x is going to be equal to 1, or the intercepts of 1 comma 0 and 2 comma 0. These two are the answers written in x-intercept form. Now let's actually go and do some graphing here, and this is going to go away once I click this button and show you that I can go to my calculator and I can type in 4x squared minus 8x, and then hit graph and see that it hits the ground at 0 and it hits the ground at 2. And if I'm not sure about that, I can always go to the table by clicking second graph and see that, oh my gosh, there it is. The origin is 0, 0, and the other value is 2 comma 0. And lo and behold, there it is. There are my two values. My answers for this is going to be 0 comma 0, and my answer for this is going to be 2 comma 0. So those are my two x-intercepts for the problem. Now let's go take a look at this last example here, this 2x squared minus 3x minus 2. If I hit graph, I can make a hypothesis that that is definitely hitting the ground at 2, but that might be hitting the ground at negative 1/2. So I'm going to go second graph and take a look, and it does hit the ground at 2 comma 0, but negative 1/2. Can't really check. One of the ways I could do this, if I could change my table setup by clicking second window, I can check at negative 0.5 and see if it hits the ground at that spot. And lo and behold, it does. Because at negative 0.5, whoops, I'm sorry, I should have changed my start, not my delta table there. I can keep my delta table at 1. I can put my start at negative 0.5. And now I can see if that hits the ground at 0, and it does. Look, negative 0.5 and 0 is an intercept, because that looks like it hit the ground at negative 1/2, and it also hits the ground at 2. So I just tested, using my table setup, at the negative 0.5, and my table gave me that answer, that is one of the intercepts. Also, on the other side was 2, so let me change my start to 2 and see if that was also part of my table, and there it is. So down here, by using the calculator and doing some good estimations, I can get those x-intercepts of negative 1/2, or 0.5, and positive 2. But I know you may not have been able to think about that, a little table change there. So what I'm about to do is I am about to help you a little bit by doing some tricky trinomial factoring. And so if I want to do this with trinomial factoring instead of quadratic formula, I would multiply this 2 by the negative 2 and get a negative 4. Now, the two numbers that add up to make negative 4, or multiply to make negative 4 and add up to negative 3 is going to be, let's see here, a negative 4 and a positive 1. I'm really going through the factoring of a tricky trinomial using this method of getting this middle number split into these two terms. I am then going to group these. So the number that I can factor out of these two terms here is 2x, which leaves me with x minus 2. And what I can factor out of here is a 1, which leaves me with an x minus 2. Using the grouping method, I will now have the factored form of x minus 2 and 2x plus 1. If I set these equal to 0, x minus 2 equals 0 is x equals 2. Oh, well, will you look at that? And then if we have our x, or 2x plus 1 equals 0, I subtract the 1, so 2x is equal to negative 1. Divide both sides by 2, x is equal to negative 1/2. Well, will you look at that? So whether you want to use graphing or the quadratic formula or factoring, you'll be able to easily find your zeros of the equation, and then you're going to write them in x-intercept form. So we're going to take a little break from this for right now. We're going to actually go to this part of this worksheet I've created. It talks about the discriminant. Because it says here, use the discriminant to determine the number of x-intercepts. This isn't going to tell you where the x-intercepts are. It just tells you the quantity of the x-intercepts of the parabola. So I've made a little chart, and the chart is for the discriminant. And to remind ourselves, what is the discriminant? Now, the discriminant is what was underneath the square root of the quadratic formula. Our quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, what I'm about to do with a different colored pen here, if I choose this light color, this in the inside is my discriminant. My discriminant is b squared minus 4ac. Now, what I'm about to do is give you a little chart to help you remember this. If your b squared minus 4ac is positive, an example of this would be like the square root of 64 or the square root of 103. Anytime you get something that's positive, you're going to have two x-intercepts. So anytime this is positive or the square root of 0.5, you're going to have two x-intercepts. Now, if your square root is negative, like negative 1 or negative 16 or negative 137, you're going to have no x-intercepts. You're going to actually have two imaginary answers because all of these numbers, the square root of a negative number gives you I. Now, the last situation is if you have the square of nothing in your trailer, so you just have 0, this means you're going to have only one answer. So this is going to hit the ground in two locations. It's going to hit the ground like this, or it'll hit the ground like this, or it can hit the ground like this, and of course there's there's frowns as well if the A is negative. A negative situation will either miss the x-axis completely, or if it's negative, it would miss in that direction. Now, if you have 0, in your discriminant, that means it's only going to hit the ground once. So it would come down, touch, and then leave and go back up again. And the same thing here if it was negative. And it would also, be possible to, collide over here or collide over here. So that's what we mean by the discriminant can tell you how many solutions there are. So what we're going to do is evaluate each of these discriminants using the quadratic formula. And actually, from now till the end of this worksheet, we're going to primarily look at the quadratic formula because things are not going to be easily factorable nor graphable. So this is going to be the b squared, or negative 5 squared, minus 4 times a, and this a is going to be 3, and the c is going to be negative 2. And by computing this, using parentheses, making sure we get everything right here, we would get an answer of 49. And since this is a positive number, then we would have 2 answers in our quadratic, or 2 x-intercepts in our answer. Notice this doesn't tell us where they are, it just tells us how many answers there are. Now if we plug this into my quadratic formula, so this is going to be, or my discriminant of the quadratic formula, this is b squared minus 4 times a times c. What this gives me, it gives me an answer of negative 20. And this means that there will be 0 real answers for this problem because there will be imaginary answers. So this graph will not cross the x-inner axis at all. So there will be no answers for x-intercepts. Here, let's plug this into, let's see, our b squared minus 4 times a times c. And if I type that into the calculator correctly, I will get an answer of negative 15, not negative 10, negative 15, which gives me 0 answers. Again. And finally for this problem, that's going to wrap up our little talk about discriminants here, I'm going to type in our b squared, so make sure the negative 4 is in parentheses, minus 4 times a times c, and if I type this incorrectly, I get the answer of 0. And this tells me that there is going to be one answer to my problem. So there's only going to be one answer. It doesn't tell me where, but it's one answer for the number of x-intercepts I have in my